All right, thank you for joining our session. Maybe I should stand here because of the microphone thing. Thank you for coming. This session is about continuous verification. And basically, now that you are using Spinnaker and deploying applications fast, you want to be able to verify the applications as it gets deployed. And that's sort of the topic of this particular talk. And we're going to show you what we have today and then what we are thinking about, what you're driving the Spinnaker community to improve that situation. And so with that, my name is Balaji. I run products at OpsumX. Actually, we are, we'll talk about our company in a second. And Michael? You want to introduce yourself?
Oh, sure. I didn't have to wait until later. I'm Michael Graff. I'm at OpsumX. They call me, a principal architect. I consider myself an engineer, very much so. And I'm primarily focused on autopilot, but also some other things there too, but mostly autopilot.
Yeah, so the thing that's good thing, interesting thing about Michael is that he was at Netflix. So he was the primary author of Kayanta, a Canary analysis service. So he joined OpsumX recently. So he brings a lot of real-world experience at scale at Netflix. So that's something we thought would be useful here. And so very quickly about OpsumX, we're a 3-year-old company. Our team comes from various backgrounds, obviously Netflix and AWS. I come from Cisco previously, but quite a bit of background. We are contributing to Spinnaker. Some of the things we contributed is Terraform, operators, and we're working on other contributions as well to enable increasing adoption of Spinnaker in enterprises. So again, we will go through what is verification as we define it, and then we can talk about what we have today and what we're driving within the community towards better continuous verification. So I think to sort of level set the motivation for the verification itself, I mean, essentially now that you are releasing things faster, what we have seen, this is a Gartner study recently, done a couple of years ago, but I think it's still pretty relevant in the sense that this is reported by, let's say, hundreds of enterprises who claim that, hey, as they increase their velocity of deployment of applications, their successful deployment, as they call it, successful deployment reduces dramatically. Obviously, it says goes to 0, but I'm assuming now the world is better, you have better success rate, but still, it kind of shows you the problem of, as you increase velocity, automate everything, you still need to verify things in a right manner. Obviously, the complexities has increased as well. One is speed, the complexity of now you're deploying to various clouds. You have microservice architecture, and that makes it difficult to troubleshoot and cross-check. And as you look at trying to verify these things, if you're doing manually, your verification cost goes up. You can't get the real velocity because you're now verifying things because you don't want to create a violation or production failures. Production failures, obviously, is bad for everybody, and obviously this is one study which says about $1 million per hour. If you're a large company and you have a bad deployment in production. And so the real problem, what we are, or at least saying here, is that the manual verification at speed is going to be error prone and slow and costly. If you look at the overall pipeline, there's a CI component, there's a CD component. And usually when you focus on verification, you're probably associating to the deployment aspect of it. Now that I deployed, I want to be able to verify what I deployed. I want to be able to make any decisions on it based on the evaluation of the application. And obviously beyond deployment also, I need to monitor and I need to be able to roll back. And the manual verification part of it, because you have multiple people potentially reviewing a pipeline run every day. If you have multiple SREs, each one is interpreting the rules of what is right and what is wrong incorrectly potentially, and you could potentially lead to the potential production failures. There's other aspects of it. In many companies, there's some sort of an offline manual approvals, offline checks of compliance. A lot of these things are done in an offline fashion. It's not even part of a pipeline. It's like, okay, I'm going to put a manual judgment step, and then somebody goes and does something and come back and say approve, right? And so what happens during that stage, nobody knows. So these things we need to be able to provide visibility, obviously, and be able to automate it in an intelligent fashion to be able to get the velocity that you really want. All right, so I think the verification, one thing I want to point out is that the verification is just not at the sort of the production rollout stage, or maybe a Canary or a blue-green kind of a stage. If you look at it, you can verify things at every stage, during the pipeline. From integration test to load test, you can still verify the current release to the previous release. Maybe it's not a Canary type of deployment because you ran the test yesterday or 1 hour ago or 2 hours ago. You can still compare, because essentially if you're going through the same test, you should be able to tell the new version how it behaves compared to the old version. If there's a flag right there, you stop right there. You don't actually let it go to staging, production, and pre-production, and production basically. A lot of things, we have seen actual real use cases where a large sort of a grocery company, they were having load test failures that they could have kept in load test stage, but it happens in production, and then they have to roll back all the way and affect users. In each phases of deployment, either you're testing or in any of the stages, you have different things you're testing. For example, obviously in the testing or the QA phase, you're obviously doing the unit test, stress test. You're also probably doing source code analysis, static analysis, or dynamic analysis. And these things has to be also be verified. We call all of these as CV, verification at the end of the day, because if you can automate all of these things, you really would have a real automated deployment solution. So doing staging is what most people do, Canary release, and then sort of a limited production exposure of applications. And in production, it's where you say, it's all good. Now I'm going to go to expose to real customer traffic. So in this case, a Canary deployment, obviously, these are obviously customer-affecting applications. You may have a staged rollout where you have deploying into one region or some regions, and then eventually lead to more regions. Maybe you're using STO where you're doing a rolling update. So these are some of the things you practice, and you want to be able to verify during each of them before you go to call it a full production done. Because the sooner you verify in this whole pipeline, the better it is to avoid production failures, right? Obviously in post-production, usually it's still not done, because a lot of cases we have seen users come to us and say, typically what happens is when the deployment is done, it's not our problem anymore. We are done, and then the production people or the SRE people manage it. It's not my problem. But that's not necessarily have to be the case. We can still have the ability, the knowledge of the new release, and then be able to compare to the past releases, even in production. So we have an ability to, for example, we should have an ability to, for example, to continuously check the production as well, and be able to roll back. So what is continuous verification? Essentially is addressing all these stakeholders. And developers has their care abouts in terms of what software they released and where they are, and if it stopped for whatever reason, they want to know what it is, and then be able to diagnose and troubleshoot their particular releases. Operation people are obviously worried about traditional things. Operation people worry about is can I deploy it? Do I have to roll back? Is there a policy violation? There's a compliance violation, and things like that. Business users are obviously worried about their business KPI and make sure that end users, the revenue is not affected. The compliance folks are worried about, are they doing security violation, enterprise violation, or application-specific violations that's happening throughout. So continuous verification should be about maintaining SLAs. We should be able to look at logs, APM, and metrics, and business metrics. That should be able to do application policies. Be able to say this application has these set of rules and regulations, and I need to be able to enforce them as part of our pipeline. The compliance violation, for example, we should be able to check, regulations like SOX compliance checks, and you have a EU zone issues, those issues, and there may be other enterprise policy like who can deploy, what they can deploy, when they can deploy, who can approve, and all those things has to be captured in this verification method. And then security violation, in terms of are there any modified behavior of the application of the software that just got released? Nobody is checking on it, and there should be a way to automatically verify these things as well. Overall, this needs to be automated. Obviously, that will really help you to really achieve the speed rather than manual and ad hoc way of doing things. And more importantly, it needs to have some intelligence built into it. So it's not just pure automation for the sake of automation, but there's some intelligence to it. So with that, I'm going to transfer over to Michael. He's going to walk us through what we can do today, and also what he's driving within the community towards the next Spinnaker. Yep.
Okay, thank you for all showing up after this lovely lunch that we had. I'm going to talk a little bit about where we are today and give some examples of the types of things where we have hooks inside of Spinnaker that we can actually make decision points. And then later on, I'll be talking about where I think we need to expand those decision points and sort of what my dream world would be in order to make certain we can do CV all the way through a Spinnaker pipeline. So today, we can Canary. We have this down pretty well. I worked on Kayenta at Netflix. I worked on Autopilot. I'm working on Autopilot now. This is a very controlled environment. It is a very specific use case. We're very carefully controlling the environment that it's as close as possible that the Canary and the baseline are in the same space. This works very well. We give a pass-fail result. Not everybody can Canary. Not everybody can Canary in production, but there's nothing that really says you have to do this in production. We even have some of our customers using basically a test suite they run against a Canary that they've run the same test suite against production, and they can compare those. And the nice thing about that is, as mentioned, you could have done that test suite on the old version last week and compare it to this week, and it's probably okay because it's still a controlled environment to a certain extent. Best practices for Canary. I'm not going to go into a lot of best practices because there are a lot of talks. There's even a workshop during, I think, right after the session starts that you can learn more about this. These are my 5 things, if somebody asks me about Canaries, that I would recommend. Once again, keep things as similar as possible because we're really trying to detect very small changes that might, and we want to know that change occurred in the Canary due to the change we made, not due to the fact that we also ran the baseline at 1 o'clock and ran the Canary at 2, for example. Compare as few metrics as possible. In the past, I've seen people with 600 to 900 metrics. If you look hard enough, you will find a difference, and that doesn't necessarily mean there's a problem. And now you have to figure out how much of a difference do you care about, which makes it really kind of washy. So it'd be better to have, say, 5 metrics or 6 metrics that each one gives a strong indicator. Errors are almost always better than success because errors actually have a very meaningful content. You know this is an error, you know it's a problem. Errors are generally better if they go down in the Canary, and so we can check directionality. If they go up in the Canary, that's bad. If they go down, it's probably okay. And the one thing that a lot of people forget about is we call this a Canary experiment. And the reason we use the word experiment is because it's set up to say, the thing we're trying to show is, are these identical? Well, we can't do that. So we're really trying to say, is there reason to believe that these are different? So it's an experiment. In the case of an experiment, you want to make certain your experiment is set up properly. So that one of the things that you want to do is say, there's got to be at least one metric that says, yes, I'm getting the same amount of traffic to both my Canary and baseline. We've had cases in the past where my previous employer, we've had cases where the Canary was getting no traffic and therefore no errors, so it passed. And that's a wonderful thing, but it was also getting no traffic, so no wonder it passed. It had no errors. Adding this particular metric and making it critical inside the Canary config makes certain that you catch this, and you would fail, and a human would then have to figure out what's going on. And the last one is try to use application metrics when possible. When you start out with Canary infrastructure, you might be okay using system-level metrics. You might be okay with memory, CPU on the whole, as long as that's the only thing running on that machine. But in the future, you really want to get application-level metrics if you can. It's not required, but it really does help nail things down because you can say which API is failing out of maybe 4 or 5 APIs, for example. And as mentioned also, Canary is really comparing 2 data sets to each other. And you can use this today in Spinnaker to compare any 2 time frames of data from metrics. You can compare one region to another if you wanted to. You can compare last hour to this hour. But every time you change the environment and you weaken that hard environmental, anytime the environment is also different, you run the risk of having higher variance. So you have to possibly consider your metric a little bit better. One of the recommendations I have here is, the hardest part is figuring out what you are going to be using as your baseline, but the next hardest part is making certain that your metrics work properly. Like for example, suppose I'm spinning up a new version and I want to compare it to a running baseline. I might have 5 copies of the running baseline running. I can't just use queries per second because I only have 1 instance of Canary and I have 5 of the baseline. That's not going to work. So maybe I have to use successful requests as the thing to divide everything by. So it's errors per successful request. it's memory per successful request, or incoming request or something like that. Latency is probably good across the board because latency shouldn't change. You're really trying to detect changes where the system is behaving differently, so latency just sort of works directly. And I would weaken what my expectation of this sort of test would be. A Canary, we can say pretty clearly this is different. But in this sort of test, this is for the really big errors. This isn't going to find a 1% variance reliably, because you're probably always going to find that. But it would find a huge error, like my latency has gone up by 40%. Well, that's really bad. Or my queries I'm returning far more errors than I was before. That's also really bad. Beyond Canary and beyond using Canary for generic A/B sort of comparisons, we do have webhooks inside of Spinnaker. And this works pretty well, but it's a stage, which means it has to go between another stage. So you have a deployment stage, and then you have a webhook that can check to see if there's health by calling out to some external system. The problem is you've already deployed, and I'll get into why this isn't quite sufficient later. But you do have webhooks, so you could, in theory, use a webhook to call out to an external system and say, has an alert triggered, or some such thing. We also have health provider checks coming in from the cloud provider itself, but really that just means, did the instance come up? It might mean, did the instance come up and the application is listening on the port? But that's pretty much where that stops. It doesn't check the application health. And of course, for those who really like pushing buttons and waiting on things, we also have manual checks. I've said a long time ago that untested code is broken. Unmonitored machines are broken because I can't trust that they're not. I also think unautomated repetitive tasks are broken. So if you don't automate a repetitive task, it might not be broken today, but it's going to be broken tomorrow. So manual checks for me are more for a safety check. It's places where I might want to override an automated decision because I don't trust that system yet. I don't have enough experience with it, but I wouldn't use it in standard production pathways until there's a problem. So we use it a lot for an initial check. We might want to say, let's run this Canary config and see if it works, but I'm not going to trust it 100%. I don't want it to go to, I want it to, if it's okay, it's okay, but if it fails, I might still want to say okay, because it might be my config that's broken. And that slide is supposed to be skipped. So I'm going to have Balaji come back up for another few examples here. And while he's going through this, this is an example of what we can do today in the Canary technology. Think about the different places that you might want to add checks into the system that we want to have in Spinnaker that are not just a Canary stage all by itself.
All right. Give me a second. So I'm just going to show you, obviously, I'm not sure, everybody has seen Kayanta here? Or? Okay. I just want to give you a quick overview of some people who haven't seen it. Obviously, you can set up Kayanta, which is part of the Spinnaker open source that Michael helped write. And you could specify, for example, something called a config, where you specify what metrics you want, and you can group the metrics and also give weights to the metrics. So when you run the analysis, it basically, these are all the metrics that you select, right? From, let's say you have a Datadog or Prometheus, for example. It's basically a metrics that you select. And in this case, there are a few metrics selected, and then you run the Canary stage within Spinnaker, and then you get results. Basically, it compares all the metrics you just asked it to compare and do a statistical comparison between the two versions of software, the Canary and the baseline, and basically provides you a score. In this case, it's a 100 score because everything is similar. But you would see that if there are variations, significant variations, you would see you get a different score, and you would be able to look at it. So this is a very useful tool that we have. So one of the things that we at OpsMax have done, I want to just do a quick show there, is that what are some of the things that we can do today that I think we should, as a community, should be doing. So we're working on how to open source some of these components as well. But for now, I'm just going to show you what we're doing right now. So you have the Canary stage, and you can get a score from as part of the pipeline. And here we are showing that this is something we have done where we're comparing the logs. For example, in this case, we are comparing two releases, a baseline and a baseline and a Canary version, and identifying For the logs, we use natural language processing to identify the errors and critical errors and warnings as you find in the new Canary release, and then be able to look at things. For example, in this case, it shows you how many times this particular error message was repeated. It's automatically categorized as a critical error, and then you can also see during which, if you have run the particular analysis for 1 hour, it tells you, is it happening in the beginning of the test or during the certain parts of the test. So you can see here some critical errors, which basically that's why the result of the score was 0. And there's errors, it shows you the number of times a particular error message was repeated, and then there's a warning, and etc. So you can obviously reclassify some things. For example, if the natural language processing or the algorithm is finding something that's severe, and you say, it's really not severe, it's warning, for example, or just ignore it, you can reclassify them, and then this will learn, and for the next time, you would not have to do it. So again, this works with the existing Spinnaker. Obviously, as you can see, it is a little bit beyond Kayenta. Kayenta was just comparing metrics. This is now comparing logs. And the other part that Michael was pointing out is that we need to go beyond the I/O metrics and the compute metrics, etc. You need to go beyond to application level. So in this case, this is an API level comparison between the baseline and the Canary. Again, it's let's say in this case a particular API endpoint. It has a latency, error rate, and throughput, and those kind of things. You can see that the baseline, so that the Canary is much higher latency compared to the baseline, and obviously this failed the score here. Again, these are all sort of incremental things from what Kayenta was doing in terms of just looking at the metrics to log and APM and other kinds of metrics. With that, I'm going to give it back to you, and you can continue on with I think you want to add maybe a few words here on.
Sure. All right. So one of the things I've learned about public speaking is I always speak faster when I'm actually doing the speech. So we're going to finish a little early. Hope everybody's okay with that. So Autopilot is really similar to Kayenta. It has the same API, and it works in a very similar way to a certain point, but it is a more advanced version of it. We do more math behind the scenes, and also we have the log processing. Those are really the important parts of our particular application, that we do want to open source parts of it and possibly merge the parts that we do have into Kayenta. One thing about OpsumX is we're very focused on the open source world. We think you should have pluggable models. It should not be something that we sell you and then you're bound into a version of Spinnaker for OpsumX that you have to use, for example. Let's see, let me go on to this one. How do I get to full screen again? So now I'm going to talk a little bit about the future. Where are we headed? Where do I think we could go? This is not necessarily a perfect path. I need a lot of input, and we are working with a lot of people on this. So I would like to see checkpoints at multiple places within Spinnaker. I don't think it's sufficient to have a stage that makes a decision. I think the stage itself needs to grow the ability to make a decision inside the stage. One of the stages that I really recommend for deploying software, if at all possible, on the cloud provider you're using is the rolling red-black. And that's where you might roll 10, suppose you have 10 instances of a server that you're trying to roll out. You might roll out 10% of those, the new version, and then do a health check. And then another 10% and do a health check until eventually you get to 100% of the new code. Right now, the rolling red-black will do that, but there really isn't a good way to hook into generic health providers to say, is it actually working, or am I causing a problem? And I think that's for an example of what we need to do. Stages could learn, based upon the health check they get, what action they might take. And that could be a deployment stage might roll back or cancel itself or undo or pause or who knows what we want to do there. But the idea is that safety, I want to run as fast as possible, but I want it as fast as possible, but as safely as possible. So those health checks need to be distributed throughout. These are some of the health checks I've heard of, and as well as some that I thought up myself based upon experience here. We don't have a good threshold system inside of Spinnaker right now. It's hard to even say something as simple as, am I meeting my SLA for latency during this deployment? We don't have that right now. I think Kayenta, for example, could grow that quite easily, and then we could call it to Kayenta once the hook is in place. A really interesting one that I'd like to see added and this is possibly a community offering, not necessarily something inside of Spinnaker again, is a downstream and upstream and especially downstream view of what our application looks like. A common outage I've seen is I'm deploying my version, the downstream who's calling me calls my new version, and for some reason doesn't like the response. So it does a retry, and it gets the old version, and it works. And so far there's no outage. Nobody's noticed anything. During a Canary, there's so little traffic increase, nobody actually notices this problem. During a rolling deployment, at 10%, now that problem is suddenly more visible, and at 20%, I'm starting to see significant retries from the downstream. And I could make an intelligent decision that maybe I should stop rolling out my version. Upstreams are similar. I might be putting additional load on an upstream that they weren't expecting before. But at my previous employer, downstream was more important than upstream. It's almost always I've added or changed a field or some way that they're not quite ready for, or I'm giving them additional data that they weren't expecting, and they don't like that. But we also, most of us have alerting systems, I suspect. Most big companies have an alerting system that they already trust and it's already built in. So why can't Spinnaker call into that and ask questions? And while we could do that as a webhook stage, it just seems like it'd be really good to do it in the middle of a rolling deployment and not have to do other stages between everything and then trying to manage that scale. It just gets pretty messy pretty fast. There's also environmental indicators. Oftentimes DNS is down in one zone or something is wrong with one particular region, and you might not want to deploy that region or even not deploy at all. And these are unrelated to your application, but the idea is that if I continue the deployment, I might cause an outage. It's better to let things sit still perhaps than anything else. I mentioned log analysis here because almost everything is either on a health indicator or a metric. Log analysis would be awesome. There's probably other things we can do there too, maybe memory pattern analysis or call traces. And compliance, security, the common checks that we have to do to make certain that we all remain legal and we all remain sane, which engineers like myself, as mentioned, understand exists, but aren't so concerned about other than they need to be there. And a big one for me is also verification of deployments. People can, in some cases, go on and fiddle with configs on side of running instances. It'd be often nice to know that happened, so that we can say, we're not going to deploy because somebody has made a modification to this config, and we're going to overwrite that, which might actually cause an outage. One thing I want to stress again is that we are trying to build an ecosystem. We're not trying to say, this is the OpsumX way we want to do things. We want to build a system where it's pluggable, multiple vendors can come along and add their special sauce in, and with the open source Spinnaker, you're still able to use all the tools you want to build the things you need to get your safety level that you're looking for. I'd like to point out we have a SIG started for this particular task. It is the unfortunate name of operational validation. I needed to pick a word, and I chose those two. We currently have the three people mentioned here, Matt Duffler, Michael Graff, myself, and Chris Sandin. We are the three people who focus primarily on Kayenta. So we're the three people who generated that Kayenta originally. And we're trying to build a framework where we can actually evaluate different techniques and different systems and how them hook into Spinnaker and how they should hook into Spinnaker, specifically focusing around the decision points that we're trying to do. And there is a talk later on, I think it's today, about pluggable Spinnaker, and this is something we're also very interested in for Kayenta specifically, but also for Spinnaker as well. So we have many related sessions. One is already on video, so you're going to have to watch it on video because it's already occurred this morning. That's the Journey to Safe Critical Mission Continuous Delivery at Descartes Lab. We also have an automated Canary analysis workshop, which I mentioned. If you're interested in that, that happens at 2:30. It actually is 2 hours long, so you don't have to show up to the whole thing, but it'd be good to show up to at least the first part of it if you're curious, if you're, I guess, Canary curious. We also have another talk here on Sunday, 12:30, and we have a talk at 1:30. And I don't want to downplay the middle one here, but we actually have, I'm very interested in the middle one, because Referee is a system built at Nike. And Kayenta, when we built it, was originally designed to be a standalone tool as well as a part of Spinnaker. And this is a UI on top of Kayenta without using Spinnaker. So even if you're not using Spinnaker today, you could still experiment with Canaries using Referee, which I think is pretty awesome. It shows that's once again, we're trying to build an ecosystem here. We're not really too biased on how people use our tools. We just want them to get the best use out of it. I think we have questions. Anybody have any questions?
Yeah, so if you, you can see our contact information, so feel free to reach out. If you want to evaluate autopilot that I showed you, you can use the email as well.
There's nothing to do.
Any questions that we can answer at this point?
So you're trying to, for
Maybe speak
validation, you're trying to have some kind of modules for listening logs and all that. How about tapping into existing APM solutions?
Oh yeah, that's the plan. So my point is that I want to have Spinnaker be able to call out to existing solutions. We are building one that I talked about a little bit, and we presented that more to show this is the kind of thing we want to tap into. My goal is to make Spinnaker not care about what it calls. Maybe there will be some configuration that you have to call some specific
You
thing.
really get some plugins or whatever. Right?
Yeah. I didn't do a mock-up or anything, but perhaps I should have. The idea that I'm thinking of is there will be health checks for an application, and then in the stage you can say, I want to pay attention to these health checks by default, and I skip this one because for some reason it doesn't matter for this stage, perhaps. But you might have did any alerts fire? No, great. Are our metrics within SLA requirements? Yes, great. Did the compliance framework check us out and say yes? Okay, great. Now we can continue to the next stage.
So I think I think the APM, the one example I showed you where it's showing the latency, and this is actually to the New Relic that's there, right?
Okay, it's coming from.
That
I
is-
was like, why you build something? which is
No,
already built
no,
with
it is coming from
Yeah.
New Relic. It's just shown in this context because at the end of the day, you're trying to evaluate the whole thing. You're looking at the logs, you're looking at the New Relic, you're looking at the Prometheus, etc., all in one consolidated reporting, right? And that's just a tip of the iceberg. There's a whole bunch of things we need to check: security evaluation, compliance. If you look at it, that's sort of the whole thing. You would feel comfortable, right?
Yeah, rather than looking at building everything, tap into existing.
That's
scenarios.
exactly how it's done, right?
Yeah, this is more about the idea that Spinnaker needs to be able to tap into those things and where it needs to tap in. Because right now you could build a stage that said call out to a particular APM solution, but now you can only do it between stages. Like a rolling red black has already occurred; it's done. You can't go back and undo that easily. And plus, you may have caused an outage. It'd be nice along the way we could check those APM solutions.
Yeah, so the value add essentially is now we look at the baseline and the Canary and try to give you the comparison. And there's a historical way to understand the thing as well. Like there's a history behind it, not just a point in time comparison in some ways. Yeah, and then also you can set rules and policies and things like that that is sort of specific to an application. The primary atomic unit is an application or a microservice, for example, right? So you have a different view if you're looking at that from that angle versus if you just go to New Relic and look at a specific metric and things like that. So we're trying to sort of make this as a validation of a service or an application, and it has multiple components to it. Yeah, we can talk more, I think, offline.
How much of it is going to come into open source?
Yeah, so you can
So-
comment.
So for the framework that calls out, I hope all of it. I'm a big open source proponent. I've worked on Bind 9 in my past, so DNS World, and I really want open source everything. So I understand that, we have secret sauce just like everybody else does that keeps the lights on, but I would like to keep as much in the standard open source Spinnaker as possible, because I think that's the value. I'm not really against, I don't want to say no company should do this, but I would prefer to see open source solutions where you can pick proprietary implementations of certain features and pull them in, rather than being tied into a specific. You have to use our version of Spinnaker to get these features that are our special sauce. Because now, how do you get another company's special sauce at the same time?
Yeah, so
I want the a la carte.
the operational validation SIG is sort of that neutral party, right? That's
Yeah.
sort of bringing that whole thing to the Spinnaker, and then there's obviously some implementation that the open source. We can also open source, and anybody can open source. But the goal is to be Spinnaker OSS.
And we haven't actually had a SIG meeting yet, but all three of us are now physically in the same area. So we have the plan to get together at some point and actually say, when are we going to have our first meeting?